And the last biomolecule alive is nucleic acid, and this includes DNA and RNA. And there is some differences between DNA and RNA that we're gonna talk about next. So nucleic acids. So a nucleic acid is composed of a sugar, it's composed of a phosphate group, and is composed of nucleotide bases. So the sugar and the phosphate group makes the backbone of DNA and RNA. So there are five bases. So you have adenine, guanine, cytosine, thymine, and uracil. So let's talk about the differences between DNA and RNA. So the first difference is that DNA is composed of two strands. This is in contrast to RNA, which is composed of only one strand. In the case of the sugar that is found in DNA, it's deoxyribose. This is in contrast to RNA, which the sugar that is found in RNA is called ribose. And when it comes to the bases, so the four bases that are found on DNA includes adenine, guanine, cytosine, and thymine. When it comes to RNA, three of those bases are the same. So adenine, guanine, and cytosine are also found in RNA. However, thymine is substituted by uracil. Again, uracil is found in RNA and is not found in DNA. Alright, so let's talk about why is water so important for life. As we already know, 75% of you is made out of water. But let's talk about more properties of water and why water is essential to life. Alright, so let's continue talking about the properties of water. Water is such a good solvent because it is a polar molecule. So polar molecule basically means that it has a charge. So when we talk about water, water is composed of one oxygen and two hydrogens. Oxygen is one of the most electronegative elements in the periodic table. So that means that it's hungry for electrons and it's going to try to steal electrons from other molecules. And so because oxygen is so powerful, the majority of the time, the electron that is in the hydrogen molecule spends the majority of the time near the oxygen molecule. So that this gives the oxygen molecule a partial negative charge, and it gives the hydrogen molecule a partial positive charge. So which means that this water molecule is a polar molecule, so that it has basically a charge. And specifically, water likes to dissolve ionic bonds. So not everything can dissolve in water. So for example, neutral molecules, such as for example fats or lipids, do not dissolve in water. And you can do a very simple experiment. So salt is composed of sodium and chloride. So two elements that have opposite charges. So if you put salt in a glass of water, what's going to happen is that water is going to dissolve or is going to destroy the salt. However, if you put oil in a glass of water, what's going to happen is that you're going to see two phases. So fats do not dissolve in water, and it's because fats are made out of a bunch of carbon to carbon to carbon to carbon carbon bonds, and carbon is a neutral element, so it doesn't have a charge. Now, because water is a polar molecule, that means that it has a charge. So that means that there is an attraction between two different water molecules. And the type of bond that is made between the two different water molecules, it's a hydrogen bond. And it is extremely important that the water molecules can make a hydrogen bond because it gives the water molecule different properties. And we'll talk about those properties next. Water can absorb a lot of energy. And the reason for this is because it takes a lot of energy to break down the hydrogen bonds that are formed between two different water molecules. So as soon as one hydrogen bond is broken, then another hydrogen bond is made. And this is good because it allows you, for example, to cook, right? Because it can absorb a lot of energy. A second property of water is that it becomes less dense when it becomes solid. And the reason for that is because as the water molecule becomes solid, it increases the surface area. So another property of water is cohesion. So a water molecule likes to interact with another water molecule and it likes to make hydrogen bonds. So cohesion is basically the interaction between two water molecules. Adhesion is the interaction between a water molecule and a surface. And both cohesion and adhesion are essential when it comes to plant because the water molecule has to go from the roots of the plant all the way to the leaves of the plant. And it's because in the leaves of the plant, that's where a plant is doing photosynthesis and water is involved. And as we already mentioned, solid water is less than the liquid water. So that means that ice floats in water. And the reason why it floats is because it increases the surface area. So another important property of water is that it can act as an acid or a base. So water is the buffer system that we have in our body that ensures that the pH of the blood is close to 7 or is basically neutral. So the pH scale is the scale that measures how acidic or how basic a substance is. And that pH scale ranges from 0 to 14. So the closer to 0 you are, the more acidic you are. And the closer to 14, that means the more basic you are. And if you are around 7, then that means you are neutral. You're not acidic and you're not basic. Again, water acts as a buffer system in order to ensure that the pH of the blood is close to 7 or is basically neutral. So water can act as an acid or a base. So water can act as an acid or a base. So acids have a higher concentration of hydrogen ions, and on the pH scale, they are closer to 0. So the closer you are to 0, the more acidic you are. And some examples of substances that are acidic include orange juice, coffee, and the acid that is found in the battery. Bases have a lower concentration of hydrogen ions, and on a pH scale, they are closer to 14. And some examples of substances that are basic include baking soda and also the liquid detergent.